In this next project, we tried to address some challenges with the fabrication of these structures. How can we make these structures over large areas? How can you have very high transmission? How can we have good clarity, low haze, and also provide for anti-fogging and abrasion resistance? So as I mentioned, the Glasswing butterfly wing is inspiration for making these types of structures. And we made these structures using a reactive ion etching process. So this is a high dimensional input parameter space. You have a variety of different types of gases, different processing conditions such as the etching time, the power of of uh, of the etching, the pressure of the in the chamber, as well as the deposition of silica. The three parameters that we're trying to optimize in this case, we're trying to maximize the transmission, we're trying to minimize the haze, the amount of light that's scattered, and we're also trying to provide for a high oil contact angle. So we use Bayesian optimization to build a model using Gaussian processes, and then use this to have create a acquisition function for where we should perform additional experiments and iterate. So this gives an example of this for those three different parameters: transmission, haze, and contact angle. We have a variety of observed data points. The Bayesian Learning builds a model based on these data points with confidence intervals as well. And then based on the acquisition function, we have additional experiments for us to perform, and we iterate based on this. So this collaboration was resulted in this paper that was featured on the cover of Materials Horizons. You can see working together with machine learning and human knowledge, human intuition, creating this glass that's inspired by the Glasswing butterfly, which has a very high transmission and is also repellent towards a wide variety of liquids.